Next is question number 66, which says that if y is equal to mod of sine x minus mod of cos x, then dy by dx at x equal to 5 pi by 6 is equal to. Now here we can see that at x equal to 5 pi by 6, that is in second quadrant, y can be written equal to, as sin x will be positive, it will be equal to sin x, and cos x will be negative, so it will be written as plus cos x, right? Hence we can say that dy by dx will be equal to cos x minus sin x. So the value of dy by dx at x equal to 5 pi by 6 will be equal to cos of 5 pi by 6 minus sine of 5 pi by 6. Now this can be written equal to 5 pi by 6 means pi minus pi by 6. So we can say that it will be equal to minus of cos of pi by 6 minus sine of pi by 6. So it will be equal to minus 1 by 2 minus root 3 by 2. Hence the correct answer will be option number 4. Next is question number 67. The value of limit x tending to infinity sine of 5 raised to the power x upon 5 raised to the power x plus tan inverse 7 raised to the power x upon 7 raised to the power x plus cot inverse 9 raised to the power x upon 9 raised to the power x is equal to. Now here it can be written equal to limit x tending to infinity sine 5 raised to the power x upon 5 raised to the power x plus limit of x tending to infinity tan inverse 7 raised to the power x upon 7 raised to the power x plus limit x tending to infinity cot inverse 9 raised to the power x upon 9 raised to the power x. Now here in the first limit we can say that sine of anything will always go from minus 1 to 1 and the denominator is tending to infinity. So the first limit will be equal to 0, right? And in the second limit also similarly we see that tan inverse of something will always go from minus pi by 2 to pi by 2 and the denominator is tending to infinity again, hence the value will be tending to 0. And in the third limit also we can say that cot inverse of anything will always be between 0 to pi and the denominator is tending to infinity, so the third limit again will be equal to 0, right? So the correct answer will be 0. Next is question number 68, which says that if fx is equal to sine of GIF of x square into pi upon x square minus 3x minus 18 plus ax cube plus b, where x is going from 0 to 1 and it is equal to 2 into cos of pi x plus tan inverse x when x is going from 1 to 2. If this function is a differentiable function in 0 to 2, then the value of GIF of a plus b is equal to. Now here firstly we can observe that the value of sine of integral value of pi, that will always be equal to 0, because we know that sine pi, 2 pi, 3 pi all are 0. Hence this value will be equal to 0. So we can say that fx is equal to ax cube plus b when x is going from 0 to 1, and we can say that it is equal to 2 times cos of pi x plus tan inverse x when x is going from 1 to 2, right? Now as this is a differentiable function, so it is continuous function also, right? So we can say that at x equal to 1, as this function is continuous, so we can say that at x equal to 1 minus fx is equal to a plus b, and at x equal to 1 plus, we can say that fx is equal to 2 times cos of pi, that is minus 2, plus tan inverse 1, that is pi by 4. Now these two values will be equal, hence I can say that a plus b is equal to pi by 4 minus 2. We can say that GIF of A plus B will be equal to, now the value of pi is 3.14, that is 3.14 upon 4 minus 2. Hence, its value will be equal to minus 2, right? So, the correct answer is option number 3. Next is question number 69, which says that if fx is continuous and differentiable over minus 3 to 8 and f dash x is going from minus 4 to 4, then the maximum value of f of 8 minus f of minus 3 may be equal to. Now, in this question, we will apply Rolle's theorem in A to B, that is minus 3 to 8. So, we can say that f dash c will be equal to f of 8 minus f of minus 3 upon 8 minus minus 3, that is equal to 11, right? Now, we know that f dash c is going from minus 4 to 4, so we can write it as minus 4 is less than equal to f of 8 minus f of minus 3 upon 11 is less than equal to 4. Hence, we can say that f of 8 minus f of minus 3 will go from minus 44 to 44, right? So, the maximum value of this may be equal to 44. So, the correct answer will be option number 1. Next is question number 7, which says that the line y equal to root 3x minus 3 intersects the parabola y square equal to 2x plus 4 at A and B, then the value of PA into PB, where P is equal to root 3 comma 0 is equal to, let us say the parabola is something like this, and this is the line which intersects the parabola at point A and B. Let us say this is the point P as it is lying on the line. So let us say this is the point P, that is root 3 comma 0, and let us say this distance is r1 and this distance is r2, right? Now here we can say that the slope of the line is minus coefficient of x, that is root 3, upon coefficient of y, that is minus 1. So this is equal to root 3, that is tan theta is equal to root 3, that is theta is equal to 60 degrees. Hence we can say that cos theta will be equal to, that is cos 60 degree, that is equal to 1 by 2, and sin theta will be equal to root 3 by 2, right? By parametric form, we can write the coordinates of A or B as the coordinate of P, that is root 3 plus minus r into cos theta, that is 1 by 2, comma 0 plus minus r into sin theta, that is root 3 by 2. We can write the points A and B as this. Now, as this point is lying on the parabola, so we can say that y square, that is r root 3 by 2 whole square is equal to 2 into x, that is root 3 plus r by 2 plus 4, right? Now here, as r can either be negative or positive, so we are taking only the positive sign, right? So this can further be written equal to 3 into r square upon 4 is equal to 2 times root 3 plus r plus 4, right? This can further be written as 3r square equal to 8 root 3 plus 4r plus 16, right? That is 3 into r square minus 4r minus 8 root 3 plus 16 is equal to 0. Now, we have to find the value of PA into PB. That is, we have to find the value of R1 into R2. Now, here R is giving two values, that is R1 and R2. Hence, the product of both the roots, that is R1 into R2, can be written as 8 into root 3 plus 16 upon 3. Right? Now, as R1 and R2 can either be positive or negative, so we will apply here plus minus sign. Now, modulus of R1 into R2 can be written equal to 8 root 3 plus 16 upon 3. That is 4 by 3 into 4 plus 2 root 3. That is the correct answer will be option number 3.